three equations can I use? It's a 2D problem.
Some of the forces in the x,
Right.
some of the forces in the y, and then moment about.
And some of the moments about z, right? It's got to be a z moment. We don't know which point we want. So, do you like solving three equations, three unknowns? Truthfully. No. I'd rather solve one unknown in one equation. Don't you like that better? Right? You get it done like that. You don't have to set up a matrix or anything. So look at this. Look at this guy right here. What equation do you want to solve first?
What?
AX.
Good. And it's not the AX equation. It is what equation?
Some of the forces in the X.
Sum of the forces in the X.
Yeah.
So sum of the forces in the X equal. Walk me through it. Uriah, tell me what to write.
ax.
200 minus 300 plus AX equals 0. Is that right? Remember, you guys, you always have to have this here. There's a 0 on the end. So in the end, what happens? AX, or Uriah, is equal to 100 pounds. Box it in. You're done. It's a positive value. So Enrique, what does it mean?
It means that there's 100 pounds going to the right.
Right. It's because I got a positive value, the way I drew it is correct. Okay, what equation do you want to do next? Again, find an equation where there's only one unknown. If we do sum of the forces in the y, how many unknowns are in those? Two. I don't want to do that equation next. So, Eric, can you think of an equation we could do?
It'd be the sum of the moments in the z.
Yes, and what point do you want to do it about? B is a good one. Maria, is there another point that would be good to do it about?
In between the two forces.
Where the forces come together, right here. Right? If we did sum of the moments about this point, what happens to By?
It's a
It drops out. It's not in the equation because a force can't create a moment about the point where the force is. If I did sum of the moments about A, what would drop out? AY and AX would, right? So then I would have an equation with one unknown. That's what I want. I try to get one equation with one unknown.
Well,
What's that?
if we did it about B and Y, wouldn't that also drop out AX?
Oh yeah, it would drop out AX, but we actually already found AX, so we don't care about dropping out AX. We want to drop out one of the Y's.
Right.
So, sum of the moments, I always do it about the left. Again, I'm consistent on, I try to do the left most. So let's do sum of the moments about A. So Tara Lynn, you want to walk me through this? So it's BY times 2, positive or negative?
Positive.
Positive. 200 times
0 times
2, positive or negative?
2, negative.
Negative. 300 times
2,
positive or negative?
negative.
Negative. And 100 times
9,
9, positive or negative?
negative.
Negative. Equals 0. BY is, I got 950. Did somebody else get 950?
Yes.
Yeah?
In my head.
Kyle? Did you get it?
Yeah.
Okay.
Yeah.
So, I got a positive. What does that mean?
Well, that's it's in the
Drew
same
correctly.
direction.
The BY is going up. What if I got a negative? Talk to the person next to you. If you got a negative in this one, think about it. It means more that it goes the other way. If you got a negative, what does it mean? I drew it in the wrong direction. No, it doesn't mean that. What is BY? What kind of force is it?
Normal.
It's a normal. Should it point up?
Yeah.
Yeah. If you got a negative, what does that mean? You made a mathematical mistake. Because there's no way in hell it's going down. Right? This is a normal. If you want, call it N. You know, call it N, because then maybe you'll remember. A normal always goes towards the body. If you got a negative for a normal, call it N for normal. Okay? Call it N. And if, here, let's change all these. N, there's only one N. Let's change all of them to N's. N. I know when I get an N, I better never see a negative. Because if I see a negative, there's a problem. What about a tension? If I get a negative in tension, what does it mean? I made a mathematical mistake, because we know which way a tension should go. What if you got a negative for the weight? You definitely, if you got a negative for the weight, you wouldn't even have to stop and think about it, because you know it would be wrong. Right? You know weight always goes down. If you got a negative for the weight, it's already a trigger in your mind. You know, because you use weight so much. Well, a negative for a normal, a negative for tension should be just the same for you as a negative for a normal, a negative for a tension should be the same kind of trigger as getting a negative for the weight.
So with compression, are we being negative?
No, it's not going to be negative. It's just going to be pointing a compression, or a tension is compression. It's always pointing towards the body.
So you should still get a positive?
You should still get a positive, because you know the direction. You know that normal goes towards the body. You know tension goes away from the body. And you know that weight goes down. So you know you picked the right direction. If you get a negative, you made a mathematical error. Okay, now what equation do you want to do? Some of the forces of the y. So, Lucas, will you walk me through this? AY. Walk me through that.
So,
Some of the forces of the y is AY.
minus.
Turn off the speaker somehow.
The speaker?
It's your speaker.
Buzzing.
I don't know where it is.
No, it's gonna be inside the,
Oh yeah, of course, I got two experts with me. How do I, come on up. Lucas, these guys, Eric and Enrique, have been working with IT. They're the ones who set up all these computers in these classrooms and everything. Pretty awesome. Okay, Lucas.
So it's going to be AY plus 50 minus.
Right, let's put N though, okay?
Okay.
But yeah, you're right.
Plus N.
Right, thanks. Should be a learning experience. You have to let tell me what you did. Lucas, and then
Plus N minus 100.
100 equals 0. So AY is equal to 100 minus N, which equals negative 850 pounds. And look what I do, because I always want things to be boxed in, so I always got a habit of doing this. Can you see? So I always, when I put the answer, I put my answer, then I write the variable again and then box it in, so I have to rewrite it again. There are 3 unknowns, we needed 3 equations, we solved it. Can we do something to check it?
Yes.
Yeah, what?
Look at the back of the book.
Do a 4th equation. So check. Some of the moments about, let's do B. Some of the moments about B. So it's AY times, where are we? DJ, sorry, you just walked back in. I'm doing some of the moments about B, right here. So AY times 2, positive or negative?
Negative.
Negative.
Negative. And then the AX is canceled, right? And then 200 times Right, I'm doing it about B. To positive or negative?
Negative.
Try again, fingers go in the direction of the 200,
Positive.
palm goes down towards B, 200. And then we have a 100 times,
Wait, why would it be positive?
I think it's negative.
That's still negative.
oh yeah, you're right. Sorry, my fault. Sorry, DJ.
Negative.
200 negative, right. 100 times 7,
7.
positive or negative?
Negative.
Negative. 300 times 2, positive or negative?
Negative.
Right. Equals 0. And AY turns out to be negative 80 or 850. And it should turn out to be that, and then that's your check. So you could do a fourth equation for a check. I want to spend, we have 20 minutes left, I'd like to spend more time on this problem. But let's just take a quick look at this one. It's very similar. So let's just do this without writing it down, we're just going to do it all in our head. A beam is loaded and supported as shown. The beam has a uniform cross-section and a mass of 275 kilograms. Determine the reactions of the supports. Well, I guess I will write some things down. You do it in a different color so you know. So given, what's given? The mass is equal to 275 grams, right? So what's the weight equal to? mg, which equals? 2695. 2695 newtons. Find, what do they want us to find?
The reaction.
Reactions at A. So, Larson, we're up to you. What do you think what is that support there at
Fixed,
A? Fixed support, and it's a 2D or 3D?
2D.
So what reaction should I draw then if it's a fixed 2D support?
Reactions in Y, X,
AY, AX, and
moment about Z.
And I always draw moments positive. And then David, what other forces do we have here?
We have the force on the triangle.
Right, the distributed load, right, which we know is going to be here.
Yeah.
What's this distance going to be since it's triangular?
This is 1/3.
1/3, so 1/3 of 3 is 1 meter, right?
Right.
It's one, I'm measuring it from the right side, sorry. But you're right, it's 2/3 if I went from the left.
Yeah, I was
Yeah.
confused between the 1/3.
I'm sorry, so this is 2, you're correct, this is 2. Wait, well, I only have to dimension one of the sides, so I just dimensioned it from the right. And then what is that force equal to? F is equal to, David?
Is it a force?
What's the force due to the distributed load? It's a triangle. For distributed loads, what do I calculate? The area. So what's the area of a triangle? 1/2 base, which is 3, times the height, which is 4,200. So F turns out to be what? 2163 hundred newtons.
Wait, why is the height 4,200?
Oh, because that's what they told you it is. This right here, this number that they're giving you, here it's 0, right? And then it goes up linearly, and the max right here is 4,200 newtons per meter. So if I drew it on a graph, it's 0, this is the slope, and here's the height here.
Okay.
So the width and not the base is 3, and the height is 4,200.
So, Joanne, is that 1 Newton at 4,200 meters? Or is it 4,200 newtons at 1 meter
4,200 newtons per meter.
per meter?
So every meter, it's 4,200.
So the height is
So
not,
when I go,
so the height's not 1 meter?
No.
4,200 meters?
remember it's always given as, remember omega? On distributed loads, you always have omega, and it's always the force per the length.
Right. So if you had 4,200 newtons and 4,200 meters,
No, 3 meters. It's 4,200 newtons per meter.
right,
So if it was actually, if
It's
it was a
4,200.
rectangle,
right,
if it was a distributed load of a rectangle, it would be 4,200 times 3, because it's 4,200 newtons per meter. But because it's triangular, it's 4,200 times 3, but a half, because we're looking at a triangular area.
yeah.
So it's only 4,200 newtons at the highest
the
point, right?
At the highest point.
So it's not, it's changing.
It's, yes, yeah, it's variable. Yes, if we did integral, we would say, yes, you're right. Did everybody hear what Rachel just said? I think her explanation was the best, that it's only 4,200 newtons per meter at the highest point.
Yeah, but I think what he's saying is that it is only 1 meter, that length.
That's to
If
the
the
center.
force
The height?
To the
Yeah,
center.
the force
it's not
center
the-
is 4,200, but the length would only be force over length, so.
Are you talking about height?
Yes.
Okay, I don't even think in terms of height, because this is all calibrated, the Y value is calibrated on its newtons. It's not calibrated on its height.
Right. That's what was confusing me.
Okay.
I thought it was one half based on height, and we have a height of 1 meter at 4,200 newtons.
No, the height that we're dealing with is its
It's-
value of its force.
Right, it's in Newton meters, and I was thinking
Right.
of it in meters.
Okay, yeah, no, we're not calculating area for carpet, which would be dimension, a distance times a distance. We're calculating the area based on one dimension being a distance and one dimension being the loading per
Right,
meter.
Right.
Okay, good, I'm glad we figured that,
And
clarified
are we doing
that.
the distance from A? Because I see like the centroid is in a different location in the triangle. But it's not 3, it's really 5 from A.
Right, and you can measure it from A, because we might do some of the moments, we have to add it. But for me, it's easier for me to just look at the isolated triangle and put the dimension where it is on the triangle, because then I could come back and add 3 if I'm doing a sum of the moment about A. So I'm looking at a triangle, I want to
Well,
find
shouldn't
out
it be
what the,
2/3 then? Should 1/2 to 2/3?
right, so it's 2/3 and this is 3. So if I had a trapezoid, right, this force, the force of this thing would be here. This is section 1, F1, and this is section 2. And this is F2, right? And then if this length here is L, I know that this distance right here is L over 3. And I know this distance here is L over 2. So I wind up putting the centroid of just that geometry. I had a lot of good questions that are coming out of this problem. I have the answers up there. It's kind of, the workshop thing is kind of out, it's outside the scope of the course. It's just to get you thinking another way. And what you needed to do is find the components, but I don't really want to talk about it because it's not really, I'd rather spend more time on this so that you're prepped for the spring break when you're doing the homework. We could come back and talk about that some other time. Yeah. Just do what you can. I mean, I'm not gonna grade it based on if it's wrong or not. Okay? All right, ready? So, let's just continue, so we did given, fine. Okay, so what do they want us to find? Dave?